guys, Physics in the Flesh is back with another circular motion problem, Satellites and Weightlessness, Part 2. A Ferris wheel 22.0 meters in diameter rotates once every 13.5 seconds. What is the ratio of a person's apparent weight to her real weight, A at the top and B at the bottom? So first things first, let's draw a picture. So I'm dealing with the Ferris wheel here. So here's my wheel. I've got the person at the top. And you've got the person there at the bottom again. Now at the top, let's look at our forces. We've got the normal force going up. I realize I'm going into the text there, but hopefully you can see the orange color. There's the normal force going up. We've got our force of gravity going down. And we've got the same situation in the bottom. We've got our normal force going up, force of gravity going down. Okay, now in the two different situations, the top and the bottom, I'm always going to let positive be the direction towards the center of the Ferris wheel. It just makes the problem a whole lot simpler. So here's the thing. We're looking for the ratio of the person's apparent weight. Apparent weight is normal force to her real weight. Okay, so the real weight is Fg. So in order to find the ratio, we are looking for Fn over Fg at the top and at the bottom. So let's do that. Let's look for this ratio. So for part A, at the top of the coaster, at the top we're going to let positive be down again because we want it to be towards the center of the circle, since that's the direction of the centripetal force. So we do our Newton's second law. In this case, the net force is centripetal because it's circular motion. Okay, this is mv squared over r. In my centripetal force, with the downward being positive, it's going to be Fg minus Fn. Okay, so then we get mv squared over r. Okay, Fg is mg minus Fn. I'm going to rearrange this for Fn. You know what? When I do the ratio Fn over Fg, Fn I don't know. I have to figure out an expression for that. But Fg, I know, it's just mg. So it's going to be something over mg. So I got to figure out what that something is by solving for Fn here. So Fn, if I bring the minus Fn to the left, and I bring the positive mv squared over r to the right, I'll get Fn equals mg minus mv squared over r. Okay, so there's my Fn. So far, so good. Okay, so if I do that, then my ratio, which is Fn over Fg, I'll calculate like the following. Okay, so I do Fn over Fg equals, so here's my Fn, mg minus mv squared over r, divided by Fg, which is mg. Okay, so now the nice thing is all the masses cancel out. So you get m all disappearing. Imagine factoring out the mass from the numerator. That'll cancel with the mass in the denominator. Okay, my next step is to plug in the values. So for g, we get 9.8 meters per second squared. Let's see, and then we've got our speed. Now, what is the speed of the roller coaster? Well, we didn't actually find that out yet, did we? Okay, so the Ferris wheel is 22.0 meters in diameter, rotating once every 13.5 seconds. Okay, so let's actually do a quick speed calculation on the side here. Speed is distance over time, and the distance you travel in a circle is the circumference of that circle, so 2 pi r, and the time to go around a circle once is the period, capital T, 2 pi r over t. The radius of the circle is 11.0 meters, and the time is 13.5 seconds, so 2 pi times 11.0 meters divided by 13.5 seconds. Plug that in and you're going to get speed to be 5.12 meters per second. Okay, so we've got that. I'm going to take that, plug it in over here, except here I have to square it. 5.12 meters per second squared, and that gets divided by the radius of 11 meters all over g, 9.8 meters per second squared. So punch this whole expression into your calculator and you're going to get the following. Fn over Fg is equal to 0.757, and that's at the top. So there's half our answer. There's part A completed. Now we have to do the same ratio at the bottom and see what we get. Okay, so at the bottom, this time at the bottom, positive is going to be up because now that's pointing towards the center of the circle. So this time Fn is going to be in the positive direction, Fg is going to be in the negative. Okay, otherwise we're going to be doing the exact same steps. So part B, at the bottom, we do our same. F net is centripetal force here. Okay, so F net equals Fc. Our F net is mv squared over r. And our centripetal force, because up is positive, it's going to be Fn minus Fg, not Fg minus Fn. Solve for Fn, therefore bring the minus Fg to the right. Fg is simply mg. Okay, so then I'm just going to switch the two sides over. Fn is equal to mv squared over r plus mg. In the previous one, it was mv squared over r minus mg, or rather mg minus mv squared over r. Okay, so there's my expression for Fn. So now I can do the ratio. So the ratio of Fn to Fg, Fn over Fg equals, there's my Fn, mv squared over r plus mg divided by mg. So again, masses cancel beautifully. Now I just need to plug in my numbers. It's the same speed. Okay, so 5.12 meters per second. That gets squared divided by your radius, 11.0 meters, plus 9.8 meters per second squared. This entire thing divided by 9.8 meters per second squared. Okay, so punch those numbers in your calculator carefully and you should get your ratio of apparent to real weight to be 1.24, and that's at the bottom. So that was a fairly straightforward problem. Essentially what you had to recognize here is that apparent weight is normal force, real weight is your force of gravity. So that's it for this video, guys. I hope you enjoyed it. Please stay tuned for video number 93, Satellites and Weightlessness 3. Stay tuned for that, and be sure to subscribe to Physics in the Flesh so you never miss a video from me.